and welcome back to AGT STEM. Today we're going to be watching a video about aluminum. So, without further ado, let's hop to it.
We've decided to make a new video about aluminium because it's a long time, over 5 years, since we made the first one, and we didn't say very much. Aluminium is a surprisingly abundant element. If you look at this periodic table here, where the area of the different elements gives you a rough idea of the abundance, you can see that aluminium is one of the most abundant metals, up there with sodium, magnesium and calcium. More aluminium than potassium, about the same or perhaps even more than iron. We're never going to run out of aluminium. The problem with aluminium is that you don't find aluminium metal in nature as a metal. It's always tied up with other compounds, mostly with oxygen in clays. You know what?
So we get aluminum from clay by extracting the aluminum.
Clays are the sort of muddy stuff that you get stuck on your shoes when it's raining. To get the aluminium out of the clay, that is to break the aluminium oxygen bonds, which are very strong, requires a lot of energy, which comes from electricity. So making aluminium is very energy intensive. That's why people like to recycle aluminium, because once you've got it, it's worth preserving. But it's fantastically important because aluminium is a very light metal. And it's often used as an alloy because the aluminium alloys are stronger than the aluminium itself. So if you're using it for aircraft or some other use like that, where you want to combine lightness with strength, then the stronger you can make it, the better. But when it was first made in the 19th century, isolated as a metal, it was terrifically valuable. And there are stories of the French emperor serving his honored guests with aluminium plates or aluminium cutlery, while the less important people had silver or gold. But those times are past, and now you can get cupcakes and things like that surrounded by foil of aluminium. Aluminium is a very good metal for making things because it has a very thin coating of aluminium oxide on the surface, which prevents it reacting with things. But as soon as that coating goes, it becomes very reactive.
Wow. Those are giant explosions. It's so cool looking.
You may have seen our video where we put copper chloride in one of these cupcake holders. First of all, I'm going to dissolve some up and make a fairly concentrated solution. I'm going to place this here, and what came out was this, or rather the copper chloride came out through the hole. It starts boiling really quite nicely. Now imagine, I was doing this for my children who were quite small at that time, and whoosh, and the aluminium was completely dissolved up, forming aluminium chloride and copper metal. In my own research, aluminium is quite important. Quite a lot of our equipment uses aluminium, not so much for the high pressure tubing that we use, because quite a lot of my research involves high pressures, but we use it for the metal blocks that we put round the tubing so that we can heat it up. Aluminium has a good electrical conductivity, and it's also easy to machine. This is a piece of equipment here where we have a tube going down the middle. You can see the diameter of the tube here. Round it is an aluminium block and an electrical heater. Now, this particular case, there was an accident or a mishap because the thermocouple that was controlling the temperature of this fell out. So the heater got hotter and hotter, and eventually the aluminium melted and poured down here. And I think this is really beautiful. Well, fortunately, I was not in the lab, or I would have got very angry with my students. But I think when it happened, it was quite exciting. This would have been glowing almost red because the melting point of aluminium is around 500 degrees centigrade. But then once it formed, originally it was very shiny, but quickly it again developed the surface layer of aluminium oxide. If you have fine particles of aluminium and blow them into a flame, then they will burn quite spectacularly, and you form aluminium oxide. Now, on the face of it, aluminium oxide sounds a rather boring compound, but it's really very useful, and we use it quite a lot in our research in all sorts of different ways. It looks like a white powder, not very exciting, but in our group, this aluminium oxide has been a fantastic catalyst. All sorts of reactions that we didn't expect have gone with this material. My students keep it in a bottle almost like a magic catalyst, and I've only been given a little to show you. It acts as a solid acid, which can be used at a very high temperature and will get various acid-catalyzed reactions of organic compounds. It will make ethers. We have made various alkenes and a whole series of different compounds, and my students still use it very much. If you melt the aluminium oxide,
the little tiny parts of the aluminum oxide, like it looks like little tiny beads, almost. It doesn't really look like a powder that you'd normally see.
Which we can't do here, but can be done industrially. You can make single crystals which are transparent like glass, and then you can grow a single crystal tube like this one, which, because it's a single crystal, is terrifically strong. It's the defects that make something weak, and so if you have just one crystal, there are no defects, and so it's very strong, so you can put a very high pressure inside this tube without it blowing up.
But you could make that tube out of metal, Professor.
But if you have metal, then you can't see what's going on inside. And we are using these tubes for photochemical reactions. So we take a light like this and shine it on the chemicals going through the tube under high pressure, and we can convert one chemical into another.
That's cool.
Do this very efficiently because the light is absorbed by the molecules that we want to react, and so we don't waste the energy on everything else. And using LEDs, which are very efficient light source, you can get a process that is very energy efficient. And it all depends on having this sapphire tube. This is synthetic sapphire. The real sapphire, the gems, have impurities in them of other metals which give them the nice colours, particularly the blue. Princess Kate has a blue sapphire ring which belonged to her husband's mother, Princess Di, before her. And so these are very valuable ones. But synthetic sapphire is also expensive, but not in the same class as a natural gem.
What can nature do that the guys at the sapphire factory can't do?
Nature has time. The people who are growing this will take hours or days or perhaps weeks to grow it. Nature can spend thousands or millions of years growing a particular gem, and therefore they can heat it up and cool it down in natural surroundings, in volcanoes or whatever, far more slowly than people can afford to do industrially. There's a lot of argument whether you should call it aluminum or aluminium. Now, There isn't a totally correct one because both forms are acceptable, but all or nearly all chemists use aluminium because it's very important to use a standardized nomenclature right across the world. And I think aluminium sounds nicer.
Hi, Professor. My question is it aluminum or aluminium? Because I want to know what to call my aluminium model.
Apparently there was a decision in 1990 by IUPAC, the International Union of Pure and Applied Chemistry, that it should definitely be called aluminium, but then they relented 3 years later and said you could use aluminum as well. But if you're a serious chemist, you really need to say aluminium, because otherwise people won't find your papers, your publications, when they search, because they'll almost certainly put an I in the name.
Well, if I want to be a chemist, gotta call it aluminium. Well, that's it for today. And we'll see you next time. Stay smart. We'll see you I already said that. Bye.